Hi, my name is Eric Wing. This video is for the IUP development community. I am introducing these prototypes for Android and iOS for IUP. Sorry, I've been told it's pronounced IUP, but I keep forgetting. The ultimate goal is to have a complete implementation for these platforms, as well as a Mac one, which I started work on before this. With this video, I want to walk you through some of the design decisions because adopting IUP to mobileisms is uncharted territory and deserves discussion. Additionally, I want to go over the Android code architecture because Android development is particularly complicated compared to other platforms, and developers without experience with Android development may have a hard time understanding how the codebase works. So I hope to clarify some of these things. To get this prototype off the ground, I'm just focusing on two simple things: Dialog and a plain old button. Button isn't terribly interesting because a button is pretty much the same on desktop and mobile. I just wanted a usable widget to drive a complete testable interface, albeit trivial. Dialog is the most interesting part because it's the starting point for any IUP app. On desktop, a dialog is pretty much a window which serves as a view container for all other widgets. You can have multiple windows on desktop simultaneously. And yes, I am showing you my native Mac Cocoa backend for IUP to represent the desktop because I wanted to remind everybody about this. But what should a dialog represent on mobile? On mobile, we don't really have space for multiple windows. Furthermore, user interface for navigation needs to be much simpler, focused, and obvious. On iOS, there is a class called UIWindow which shares similarities with a desktop window, where it is a full-screen window that serves as a view container for all the widgets on screen. A naive mapping would suggest we map this as the dialog, but the problem is multiple dialogs. UIWindow by itself isn't particularly useful without more complicated user interfaces to manage multiple UI windows. Safari can serve as an example for this. You can see that Apple has designed a special custom user interface to let users select between multiple windows. But most apps don't do this because this is actually not the common case on mobile, and this UI is kind of complicated. The more common navigation element on mobile is not arbitrarily selecting between windows, but drilling down and back through a stack of views. We start on a first screen and select an option which pushes a new view. We continue drilling down until we're done, and then pop our way back out of the stack. This is true on both iOS and Android. So my proposal for Dialog, at least as the common default, is mapped to this kind of navigation structure. On iOS we use UINavigationController, and Android we use Activity. Every time we create and show a new dialog, it pushes into the navigation stack. Since we are leveraging native OS widgets and paradigms for this, users are presented a common UI they are used to and know how to navigate back. On iOS, Navigation Controller gives you the back button on the nav bar. On Android, users know to use the back button. So these are the prototypes in action. We start at the top, and every time we press a button, we create a new dialog which pushes onto the navigation stack. Leveraging the standard built-in OS provided navigation behavior, we can back out of the current dialog and return to the preceding one. While I'll have a moment to get through these demos, I should also mention another mobileism to consider is that both iOS and Android don't explicitly quit apps, but have a notion of a background suspend and resume model, which you must handle instead. Apps can be killed behind your back when they're backgrounded, so the standard IUP event loop shutdown sequence will need to be reconsidered. I will say more things about the IUP event loop later. So now I want to introduce the Android implementation. There are a few things you need to know up front. All Android apps must be written using the Android SDK, which is in Java. You cannot escape this. Android's GUI APIs are completely in Java. Android originally was Java only, but had to cave to game developers, and they provided the Android NDK, which allows for C and C++ development. The NDK is awful. John Carmack called it half-baked. It is the bare minimum needed to get game developers off their back, and the word on the street is they only have 2 full-time engineers in the entire company working on it. The Android NDK provides very few APIs, and they have no APIs for native GUI. So to get native GUI from C, we must use Java JNI to cross back and forth between Java and C to call native Android APIs from the Android SDK. Android completely controls the event loop. This is going to impact the design and conventions of how IUP programs are written. iOS and some other platforms have similar designs, so this isn't completely unique to Android. I have a proposal to solve this, which I'll post after this video. Some of you may have heard about something called the native activity. There's a saying, a little knowledge can be a dangerous thing. Basically, native activity is terrible and not well thought out, particularly when dealing with native Android APIs. It is excruciatingly painful. I've compared notes with other advanced Android developers who've been forced to push the envelope on making the NDK and SDK work together, and we all came to the same conclusion that native activity is awful and should be disregarded. The main problem with native activity is that it runs on a background thread. This means that every piece of code you write is a second-class citizen on the platform because you can't simply just call a native function directly. Basically, everything starts dancing around async or locking, both of which are terrible to deal with in the real world as performance demands and complexity start to matter. And as people try to build new things on top of these architectures, it becomes extraordinarily complex because you need to understand what everything before you is doing with respect to threads. My design intentionally keeps Yup on the main UI thread. This keeps things simple and understandable and fast. You know code will run now and not sometime later, which could lead to missing frame deadlines in high responsiveness situations. And people who want to write new, more advanced modules can do it in the simplest way possible without having to worry about the threading rules. So to start with, I will introduce the three main classes that make up this Android implementation: IUP application, IUP launch activity, and IUP activity. Every Android application must have a starting activity. An activity is kind of like a window or view container, but not quite that. An activity is also kind of like a process, but not quite that either. But with a little more certainty, they are kind of over-engineered and annoying to deal with. But we have to deal with them since they are a cornerstone of the Android design. An activity is a context class in Android. This is kind of like a God object for Android. Unfortunately, a lot of APIs require a context parameter, including, to everybody's annoyance, some of the file APIs, so it's common to create a way to get global access to these. Application is an optional class for Android apps, but it can be useful because it is used to watch the life cycles of all the other activities in your app. Android doesn't give you clear and easy APIs to figure out if your app is backgrounded or resumed, but you can infer this by figuring out the state of all your app's activities. Application is also a context class, so there are a lot of articles on making this a singleton so you can access it globally. There is also a special file called the Android manifest, which you declare a bunch of things about your app, including what your start activity and application class are. So when we launch our app, first the IUP application gets instantiated. Then the IUP launch activity gets instantiated. The reason I have an IUP launch activity is because an Android app must show some activity to start with. But Yup's API design doesn't do anything until after you create a dialog to show it. This creates an impedance mismatch. My idea with launch activity is to be a placeholder until the first dialog is created and shown. Then I will replace the launch activity and make it as if it never existed in the first place, and the user can't hit the back button to return to it. You can see in the Android manifest the no history equals true, which makes that possible. The launch activity serves two other purposes. By the rules and conventions of Android, in order to use JNI to talk to our C code, all our C code must be built into a dynamic library. Remember, Android apps are Java-based. We cannot build a native executable file that can be run on the system. Instead, we must build a normal Android Java app and call into C via JNI, where the symbols reside in a dynamic.so library we bundle with the app. So we are required to load all our dynamic libraries before we call into them via JNI. So typically, people have a static method in the activity that gets run on startup which calls system.loadLibrary on every dynamic library you need for your app. In building systems for other people to use, it is kind of terrible to require users to modify your Java file just so they can add more libraries to the list for their own application. So this class is intended to be subclassed. Users can override the list of libraries in their own subclass. I also borrow a technique from SDL which lets us just list the names of the libraries to simplify things a bit. You can see in this example I've actually made my own subclass for launch activity and application. I expect all Yup users to do the same. The other purpose of the launch activity is that it could potentially serve as a splash screen. End users could ultimately decorate their subclass of the launch activity to show an image or anything appropriate for a splash screen. When the launch activity is ready, its onStart method will be called. This is where we want to start our Yup related stuff, which is in C. Remember that this is a Java program, so there is no int main. Instead, we must call into C ourselves to start running C code. Also remember that Android controls the event loop, so the convention of calling it IUP main loop, which never returns and effectively blocks the event loop, will not work here. So instead, I'm going to call a C function called IUP entry point to be the starting point for a Yup program. Here I call a native function called IUP entry. This follows JNI rules. Now there must be a C function with this name combined with this class's Java namespace. I put those in the files with _JNI_ in the middle of the file name. This function's job is to call a function called IUP entry point in the user's program. You will see a lot of code here, but it is ultimately just a dance to call the right function. One extra thing going on with DLSim is I'm avoiding an unresolved symbol problem with libiup.so not having IUP entry point in the library. There's also some extra code here to allow people to use a different function name by changing it in the Android manifest. So we call the entry point function, and now we're in the user's program, and things begin to look like a normal Yup program from the outside perspective. So next, let's take a look at how IupDialog is implemented for Android. We start in IUP Android_dialog.c. We ultimately want to create a new activity. This will be of class IUP activity. Since this is Java, we need to use JNI to cross back into Java. I created a convenience method in Java called createActivity to help me because you can see that all the boilerplate to interact with Java from C is really tedious. In this createActivity, we create a new activity. Though caveat, we are requesting a new activity to be started sometime later. It doesn't actually create a new activity here, so we don't get back an activity object here, which complicates things for Yup. Furthermore, the question arises on how to associate that new activity with what we're trying to do here. So I mentioned that activities are kind of like processes and kind of annoying. Because activities are like separate processes, it is very hard to share data between activities. You are expected to pass serializable objects between activities using another class called intent. Unfortunately, pretty much none of the view-related classes are serializable, so this isn't very useful for us. There isn't a temptation to use the application class as a global way to share data, but there are scary articles such as "Don't store data in the application object." Fortunately, we have a trick available to us that most Android developers don't. We are using C. We can pass the pointer address of the iHandle through the intent, since it is just a long integer in Java. Then, on the other side, we can use that long integer to get us the iHandle in C from the new activity. Thus, we have successfully shared data between activities and circumvented the limitations Android tried to impose on us. Meanwhile, back in the original activity, Yup still needs us to put something in the IHandle field. So I have a second cheat. I can create a viewGroup class, which is a container to put widgets in. Normally I would create this with a new activity and attach it there, but instead I can create a detached viewGroup and use it as the IHandle field for now. Later, when the OS calls back and creates the new activity, I will recover this viewGroup and attach it to the new activity. I will then swap out the temporary IHandle field of the viewGroup and put the activity there. When widgets, like buttons, are added to the dialog, they are actually added to this viewGroup. So this is pretty natural already. If I didn't need to save the pointer for the activity for bookkeeping purposes, I might forego the pointer swap. So the pointer swap does force me to put some extra type checks on the IHandle to verify if I have the activity or the viewGroup. One last thing I want to point out, don't forget to call new global ref to keep the object rooted to prevent Java from garbage collecting it when we store it in the IHandle field. Use delete global ref when we are done with the object. So I hope this overview gives you a sense of how the Android backend works. The button implementation is a little more straightforward, and most of the code is just dealing with JNI as you saw here. My repos can be found here. This will be a large project to complete all three of these backends, so if you can contribute in any way, whether it be code or financial, I'd love to hear from you. And I hope seeing these working initial implementations helps inspire the community. I believe completing all three of these backends is completely doable. It is simply a matter of will. Thank you for watching.